Hello everybody! In today's tutorial we're going to discuss something that I started a little bit ago, how to use the EEPROM library using the ESP8266 and writing whatever you want to its memory to create an Internet of Things device. So hang on and we'll be right back. As a maker developer, I use the ESP8266 as a cheap IoT solution, and it is really powerful, but it has a drawback. It doesn't have an EEPROM, and that is why it makes it so hard to write to it using the EEPROM library. In this two-part video tutorial, we're going to look at how to solve this issue. Part 1 of this video tutorial is going to talk about how to write to the ESP8266 and how to create a wireless access point and why we're going to do that. And we're going to finish off with a section on how to put these two together, how to write and how to connect to it with a web form that you can fill in the configuration information and then store it on the ESP8266. In part 2, which will be a week or so from now, we will actually learn how to read that information out of the memory, use it to connect to your Wi-Fi network, and build a small little IoT device around it to give you an example how to use this. Just because of the sheer amount of information we have to go through, both videos will be like 15-20 minutes long, and this is why I have divided it in 3 sections. It's what I said. The section 1 is how to write to your ESP8266. Section 2 will how to create a wireless access point, and section 3 is how to display a form on this wireless access point that you can type in your information and store it on the device. So in the description of this video I will put the starting points of each section, so what time slot it is, so if you later on have to go back you don't have to search, you just know where it is. Also, the sample sketches that we're using can be found on my blog, and the link to the blog is in the description of this video. It's also got a lot more information than this video. Well, not more, it's different. A different way of looking at the same problem. So it's a good thing to watch this video and read the blog and get the most out of it. But before you watch this video any further, go to the blog, download the sketches, and then you can start working towards a finished product. So now let's start with section 1 of this first part of the tutorial and learn how we can write to the ESP8266. So in this part of the tutorial we're going to look at a sketch called Write to EEPROM. If you have not downloaded it yet, the link to my blog is in the description. Download it, look at it, and then this will make more sense. So what we're going to do in this sketch, we're going to declare 2 variables. One is going to be a string and one is going to be a float. We're going to convert that string, that float into a string, because it's the easiest way to write to the flash memory of a ESP8266. We're going to set up the memory space. We're going to write to the memory space, and then we're going to finalize it. So let's go see how we do that. So the first thing, what we're going to do is we're going to load the variable EEPROM.h. Here we got a string value, the string variable, and here we got a float variable. Notice it has 4 decimals.
places. So it's really important to remember that. Now what we're going to do is we're going to convert the float value into a string, and we do that with this command: string the value and the decimal places. So if you notice, we had 4 decimal places. Here's the 4. If you would not do that, it would round up to 2 decimal places, and you would lose the precision of your value. This is an interesting thing. What I do is I actually add a end of string character. This is handy if you're not always sure how long your string is going to be. By adding an end of string character, when you start reading it back, when you reach that character, you know that you have reached the end of the string. Now the next step is we're going to declare a memory space, and that's not just an arbitrary value for the ESP8266. It's 512 characters. So look at it that you have a sorting rack in a mailroom that has a 512 cubby holes. It starts at 0 and goes all the way to 511. In the computer language, we always start counting at 0, not at 1. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then what we do is we write to this address, that is one of these cubby holes, and that is where we write a single string space into memory. Let's look at how we do that. We do that with a for loop. For loop is really good for that, because with this command, string length which returns an integer, you can actually find out the length of any string. So what we're saying, n can't ever be bigger than the length of string value. Simple, we know that it's 9. Starting at 0, what we do is we write the first character in the string to memory, and we flip through it every time n gets added 1 to it. So then this next one is memory space 1, character 1, memory space 2, character 2, on and on until we reach the 9th character, and then it will jump out of the loop. Last little bit is we're going to commit it, and if we don't commit it, you basically won't complete the writing, and it is not actually stored into memory. So it's really important to have this commit. So you see, it's a fairly simple process to do. Any value that you can convert to a string, which is most number values. You're going to have some issues with char arrays. Try to avoid them for this purpose, and otherwise it's a fairly simple process. So on to the next part of the tutorial. We have reached section 2 of our tutorial. So the first thing we're going to do in section 2 is download this sketch. You can find that on my blog in the description. The link is in the description. So what is a Wi-Fi access point, and why do we want to create one? That's what we're going to basically look at in this section of the tutorial. So a Wi-Fi access point is a device that gives you access to a wireless network and the services that the network provides. Now, how does that fit with an IoT project? Any device that you buy comes new out of a box that needs to be connected to your network, needs to first understand how and where to find all the information. So what you do is either you connect directly with a cable to your laptop and you type in an IP address provided, or you use an app, or you basically connect to it like you would do to a Wi-Fi router and then use an app or a web page. And that's what we're going to do. We're going to basically create a system so that you can configure your IoT device. So let's go and see how we're going to create one. To get a Wi-Fi access point, you need to configure your IoT project, you need a couple of things. You need to first have a name. They call it the Surface Set ID or SSID. We call it test. You need a password to protect it. We give it the password. You need an IP address. That's this one here. You need a gateway address. That's this one here. And you need a subnet mask, and there's this one here. What these specifically mean, if you're not sure, Google a little bit about IP networks to get a little bit acquainted, but for this setup you don't really need to understand it too much. Now the next thing we're going to do with these lines of code, which you can find in the setup function of your sketch, we're going to bind the IP information, and we do that by saying Wi-Fi soft AP config, and AP stands for access point, and then you give it an IP address, a gateway, and a subnet. And the reason why you need to know what the IP address is because later on you need to access it with a web browser, and if you don't know the IP address, you can't access it. So the next thing we do is we bind with this command the name and the password to it. So now you got your Wi-Fi access point configured, but it still doesn't do anything. So we need to add services to it, and we're going to add a web server to it. And we do that by basically creating a server object with this way, and it's listening on port 80, which most web servers listen to unless it's a secure web server or you don't want everybody to find it. If you would type in this on your web browser after you connect it to the wireless access point, this basically, this little slash here, we call it root. And this is basically, here we tell, with this command, you can find that again in your setup function. We say if somebody accesses the web server and go to root, run this function, and what's in the function I will show you a little bit. If they want to access anything else, doesn't exist, and then we handle this function here, and the handle not found function will basically display the error page that you sometimes get when you try to reach a web page not found. And then we start the server with server begin. So now we got the web server running. So let's look at the content. Sorry. To listen to the requests of a web browser, we put this in our loop of the sketch, the main loop of the sketch. A handle client basically listens for you typing in something in your web browser and pressing enter, like something like this here. And then it basically listens and it looks for if it sees this root character, because that's the only thing that we have set up. If it sees this root character, it basically goes to handle root, and in the handle root we send a response back to your request, and the response is at 200. That's the code, that's for a good web page. Then the content type is text HTML, and then the content, which is just a line of HTML that is going to display you are connected on your web browser. And if you type in anything else, like for instance HTTP setup, like this, the listener in the loop will go like, hey, I don't know what to do with it, so the page is not found, so let's go to function handle not found. And what we do is we create a string that displays some information about the web server and your request, and then basically sends that to the server as a 404, which the code stands for page not found. Again, it's text, or it's a plain text that we this time sending, not an HTML. And the content, which is the string message that we've built over here. There you go. You have a really basic setup of an access point that just displays that you're connected. Now, in section 3, what we're going to do is we take section 1, where we learn how to write stuff to flash memory, and section 2, where we create an access point, where we're actually going to create a form that you can type in your Wi-Fi configuration, and it gets stored on your ESP8266 development board. So we've reached section 2, and I just wanted to quickly, before we actually gonna look at how to do all this, is what the finished product would look like. So of course it can be nicer, but basically this is a simple input form. What I've done is I connected to my IoT device, and I typed in its IP address, and then this form is displayed. So in here you would type in the name of your Wi-Fi router. Let's call it Happy. Then you would type in your Wi-Fi password, and this is Happy. And then you would type in the IP address. So the IP address is a little bit more complex. So your IoT device needs a fixed IP address so that you can contact it when you need to or want to contact it. And most Wi-Fi routers are basically have every IP address up to 50 basically reserved. So if you look at my Wi-Fi network, would basically look something like this, and then the last 3 digits are 200 because that's way above 50. And I have sort of like a rule where I have that anything above 200 I use a configure. You can do whatever you want with it. And then with the gateway, what we're going to do is you need to give your IoT device a gateway to get onto the internet. And we're only going to use the last 3 digits. And my gateway address is basically 192.168.1.254, and that is the gateway address that I use. So the next thing we're going to do is now we're submitting it, and it basically writes all this information to your IoT device, your ESP8266, and you're ready to go and actually build the next part. We had a little bit of a preview of what the finished product looks like. So let's go and see what we need to do to actually get to that point. First thing we're going to do is we're going to download this sketch, which is in my blog, and the link to my blog is in the description. So download it, look at it, and then what we're going to do is actually combine what we learned in section 1, where we write stuff to the ESP8266, and we're going to create an access point that actually will display that form, and that's what we're going to put together. So first we're going to learn how to create the form, then how we're going to handle the input from the form, and how to write that to memory. So let's go and see how that all works. Now the first major change to that sketch that you just downloaded uploaded from the previous sketch is that we create an HTML document with an input field, with a form, an input form. And the only thing that I want to, without actually going into all the detail about HTML, because this is not an HTML course, basically you will find these things over here, and you will go like, what the hell does that mean? So sometimes when you're programming for things to be displayed as HTML, you need to use quotation marks which are part of the code, and not quotation marks that basically tells you this is a string. And to determine the difference between them is we use what we call an escape character. This slash in programming we call an escape character. So you type in the escape character, and then the character that you don't want to print out on the screen, but it's part of the code. This is how you can use quotation marks in your code without it actually being seen as quotation mark defining a string. Okay, so this is the first thing we're going to do. This is basically a variable called index.html, which makes a form. Now the next thing is we're going to look at what the differences are in the handle root. It's the same thing if you type in 192.168.1.1, you're going to get the root directory of your web server, and the only thing what we've done is we've added some stuff to it. So the first thing is what we do is we check that all the names of the input fields, so an input field basically gets created this way in HTML, and we give it a name, and that's what we're going to look for basically your SSID, your password, your IP, and your gateway. We check if these input field names are available. If they are, we go to a function called handle submit that is actually going to deal with the content of the input fields. If one of them or all of them are missing, what we do is we actually display the input field, because we will the input form, because we will assume that this is the first time you're going to enter that information. So we basically look for the name of the input field with #arg. So now let's go look at the handle root. So the handle submit. The handle submit basically what it does, it looks for these field names, but now it looks for the content. You see it says arg, not #arg. So #arg looks for the name, and arg looks actually for the content of the field. A disclaimer: if this would be a real project, you would want to do error checking to make sure that the input fields are actually that the content actually is correct, so that it's actually an IP address and it's actually a valid name for an access point, and it's actually a valid password that doesn't have characters in there that it should not have. I don't do it in this tutorial. I will show a little bit how to deal with it in part 2 of the tutorial. But let's go back. So the first thing we do is we create a web page that we're going to display, that's going to show the information that the person has typed in, and then it's going to send it to the web server. And then the next thing it's going to do is going to call a function that says write to memory, which is basically going to take each string, prepare it for writing to the ESP8266. So we do that with this here. And what we do is, you see, we put a string around it. Remember, I said anything you put the string bracket around becomes a string. So we basically give 4 strings as arguments to this function write to memory. So let's see what the write to memory does. Now, the write to memory basically does this. It adds an end of data string character to each string. You see here the SSID, the password, the IP, and the gateway. So it also tells what memory range we're going to write it into 0, 100, 200, 220. So that's where we're going to store this information. Now, why do I use this end of string character? Is because that is a character that is not allowed to be used as any as part of any of the SSID, the password, an IP address, or gateway address is not allowed to have this character. So if somebody inputs that information into the input boxes and you do error checking, it would error out on it. So we know that that character is good to be used as an end of string character because the only reason it should be there because you put it there. And what you see here is then we have another function that actually will write it to the EEPROM, or actually to the flash memory. And we do this to save on writing lines of code. So for each string, we write it to memory, and then at the end we commit it. So what does this write to EEPROM function look like? This is basically the same as we looked in section 1. We're just writing it to the EEPROM with a for loop. And so there is no big differences to it, and it's a fairly straightforward process. And now you can compile the sketch and actually see what it does and maybe improve on it a little bit.
Well, thanks everybody. I hope you enjoyed this video. If you'd like to see more of this content or really like this video, please subscribe to my channel and give this video a thumbs up. Or use the link in the description, go to my Facebook page and like my Facebook page so you automatically get updates. Another way of doing it is going to the bottom of my blog and subscribing to my newsletter. I will send that out once a month and it will only have information about projects in it, no advertising other than the new projects that I'm doing and what I'm planning to do. Well, have a great day, hope to see you soon, bye for now.